we present unsupervised 3D link segmentation of articulated objects with a mixture of coherent point drift. Our goal is to decompose articulated objects into several physical links. When 2 point sets of the rigid object are given, we generally use point set registration method to find the transformation between 2 point set. However, 2 point sets of the articulated object with different configuration, the existing rigid point set registration method would fail in aligning 2 point sets. If we can decompose the source point set into several links and take different transformations to each link, we can successfully align 2 point sets. In summary, we find the decomposition of articulated objects by aligning point sets. To better understand the kinematics of an object, we need not only a novel data set of articulated objects. We compose an appropriate kinematics chain for each object to generate physically feasible shapes. We shows a kinematic chain of a robot arm. By using the kinematics model, we generate multiple shapes of the same object. Our Coherent 3D dataset provides instance-level part, segmentation, annotation for 91,075 shapes of 92 unique models from 8 articulated object categories. This is our proposed method. Our ultimate goal is to decompose the source point set Y into several links. To enable this, we additionally need target point sets x1, x2, and x3. We will decompose the source point set into 3 links. To take transformations to decomposed links, we will recover the point set x1. Note that each link takes a different rotation matrix and translation vector. The point set x2 is also recovered from the decomposed links and transformations which are completely different from the transformations used when recovering x1. Likewise, the target point set x3 will be recovered. We optimize the decomposition matrix pi and whole transformation parameters by using the algorithm, and the objective can be expressed like this. At the beginning of the optimization, we initialize the decomposition using the general GMM clustering method and initialize rotation matrix to identity matrix and translation vector to 0 vector. As optimization progresses, the objective Q value becomes larger and we can recover target point sets more closely. At the end of optimization, we successfully decompose the source point set and align the source point set to target point sets. These are some results of the proposed method. Qualitatively, our method showed the finest result compared to the state-of-art methods in Coherent 3D dataset. Quantitatively, the proposed method attribute comparable performance to the state-of-art methods. The proposed method can be performed within 4 minutes on a local computer. There is a linear relationship between the computation time and the implementation variables k, s, m, and n. We test the proposed method on the Coherent 3D dataset under varying levels of missing points, noise, and outliers. It shows that the proposed method is robust against missing points, noises, and outliers. The proposed method cannot be applied when facing an unknown articulated object on the table because only one source point set is observed. It is necessary to create new target point sets with different configurations by manipulating the object to run our algorithm. When collecting the target point sets through completely random manipulation, sometimes not all links are detected. Only in the third case, the target point set enables the proposed method to find all object links. As such, the need for a method to gather informative target point sets leads To suggest a target manipulating point proposer. The proposer introduces m-dimensional probabilities and choices the target manipulating point over the probabilities phi. This term make the proposer sample the target point far from the previous manipulating points. This term make the proposer sample the target point where segmentation is unstable, especially near joints. At the initial state, where no target point set is given, all values of phi are initialized to the same value to uniformly sample the target manipulating point. By manipulating the target manipulating point, it collects the target point set. After that, you can run the proposed method and find the decomposition result. The point proposal probabilities can be updated too. It samples the next target manipulating point from the point proposal probabilities. By manipulating the next target manipulating point, it collects the next target point set. From the two target point sets, the proposed method can decompose the unknown object into 3 links. Quantitatively, the target manipulating point proposer consistently outperforms the randomized method. Thank you for watching.